Number 8. What type of bonding would be expected between the following atoms? Remember, we're going to do all this based on differences in electronegativities. So, A, hydrogen and fluorine. When you calculate the difference in electronegativities here, you get 1.9. 1.9 is the difference. 1.9 lands us squarely in the realm of ionic bonding. Now, when we get into B and C, we might get a little bit tricky, but A is definitely ionic. Let's take a look at B. Copper and sulfur. Copper and sulfur. Now, if you remember my quick tip that I introduced during the video lecture, you might think, oh, copper is a metal. It's a transition metal, but it's a metal, and sulfur is a nonmetal, so this should be ionic. And if you're only using the quick tip, that would be correct. However, when we calculate the electronegativity difference, the difference only ends up being 0.6. So that actually keeps us inside the polar covalent range. Polar covalent. Now, when we look at C, we have yet another problem. When we calculate our electronegativity differences for iodine and bromine, we see that it's 0.3. It's 0.3 is the difference. The notes say anything between 0 and 0.3 is nonpolar covalent. Anything between 0.3 and 1.7 is polar covalent. But what about that 0.3? Does that make it nonpolar covalent or polar covalent? In this case, it's actually on the high side of 0.3. Okay, if we had some more exactness, we could actually see that ourselves. But this actually ends up being a polar covalent bond. Now, that's not going to help you very much in terms of knowing that you were supposed to have that thinking or that thought process when you were doing this particular problem. The reason that I like to have this problem in this worksheet is so that I can tell you, I can show you that none of these types of questions, none of these types of issues where you're not really sure, right? If it's exactly on the fence, if it's exactly 0.3, is it nonpolar covalent or is it polar covalent? Which one do I pick? I'm telling you right now that none of those scenarios will be on your assessment. Okay, it'll be firmly within the nonpolar covalent realm or firmly within the polar covalent realm.